Good morning, or good afternoon, or good evening, depending on where you are. Welcome to the Longhorn launch meetup entitled Simplified Cloud Native Distributed Storage with Longhorn 1.0 GA. My name is Tom Corway, and if I can just get these slides to work, you can see a picture of me there. I'm the Global Director of Product Marketing for Rancher. I live in West London and in the UK, and I'm joined by my colleagues Sheng Yang, who's the lead architect and engineering manager for Longhorn, and my colleague William Jimenez, who's a customer success architect. So we will be your hosts for today. So first things first. If you've been to one of our meetups before, you will have seen this slide. This is an online meetup. It's not a webinar. It's not really intended that we pitch product. This is all about delivering insight. You know, we want to educate you on the development activities that we're engaged in the open source community, and this is an opportunity for us to interact with you, answer your questions, and to really sort of dig deep into the technical aspects of Longhorn, a project that we've been involved with for as long as Rancher Labs has been around. Whilst it's a meetup, there are some rules. We've scheduled, I suppose, a couple of hours for this. It might not go that long, or it might go over. We kind of a bit sort of time fluid, really, with these meetups. You know, questions are always welcome. Hopefully, most of you have used the GoToWebinar sort of system before, so you know where the questions can be asked. I will do a quick introduction, then I'll be manning the questions for most of this session, and where appropriate, I'll be sort of interrupting William and Sheng to ask your questions, and of course, we'll have a question session at the end as well. I think probably the most important thing is things will break. Be patient. You know, we're all stuck at home these days, so we're kind of hanging off the end of consumer grade internet access. So that does complicate things. Hopefully, it should all go swimmingly, and we'll have a fantastic time. But if things do go wrong, be patient. We will come back. If everything fails, there's a power cut or something, we will be back. So don't lose hope. Unsurprisingly, this meetup will be recorded and will be posted to our YouTube channel probably sometime tomorrow, I'd imagine. So you can catch up with the bits that you missed then. One of the other things we like to do as well is join the conversation on Twitter with the hashtag Rancher Meetup. If you do that, we'll get to see your picture, and it's always nice to see who we've got on the meetups, and you know who's engaged with what we're doing. Another great place to interact with us is on our Slack community channel. There are thousands and thousands of people on there. If you're a free user, or if you're a customer, if you're anybody engaged within the Kubernetes or Rancher community, it's a great place to go to ask questions. So that's the housekeeping, all done and dusted, more or less. Here's the agenda. I'm not going to speak for very long. I'm going to be looking after the sort of questions bit for most of this session, but I'm going to be doing a quick introduction to Longhorn, really setting the context for Longhorn, talking about its background, where it fits into our sort of portfolio as an open source product. And then I'm going to hand over to William, who's going to be talking about how Longhorn actually works with Rancher and really sort of digging into some of the use cases. The third section is the most important from a presentation perspective. That's Sheng's deep dive into Longhorn, and we've allowed the most time for that particular session, and that's probably what you're all here for. And then we'll have a Q&A after that, where William and Sheng will be answering questions. If there are any sort of pertinent questions that look relevant to the current sort of talk or by one of our presenters, then I will interrupt, but we'll probably leave most of them till the fourth section. So with that, I'm off into introducing Longhorn. Well, it really starts with the storage challenges around Kubernetes. Back in the day of Rancher 6.1, people used to ask us what they should do for storage. And at the time, we used to tell them that storage was like a quest for the Holy Grail. Everybody's out there looking for it, but nobody's really found it or got a good answer for it. Fast forward to today, and there are many answers. At Rancher, we're sort of invested in an open source project called Longhorn, which we think is very, very special. And really in an attempt to address the sort of classic challenges around the sort of ephemerality that we all find ourselves in the Kubernetes ecosystem. Traditional storage arrays, they're not very portable, they're not, and most importantly, they're not designed for Kubernetes, and they're very costly as well. And when you have failure, the replication workflows can be very tiresome, and it can take days to recover from failure, increasing risk. So what exactly is Longhorn, and why have we bothered with it? Longhorn is a solution for distributed replicated storage inside of a Kubernetes cluster that uses containers as storage replicas. It will run multiple replicas on different nodes, making sure that the data is synchronized between them, and then it presents a single volume to Kubernetes to attach to a workload. Longhorn 1.0 GA is a reliable, stable, easy to use and performant general purpose container storage solution that will fit the majority of use cases, but it won't fit every use case. And at a 1.0 release, we're not pretending otherwise. It's been around for a while. It's been around as long as Rancher Labs has been in existence, about 4 years. We've been working on it for quite some time. So it's useful to understand the context of Longhorn, really to understand why we think it's such an important component of our sort of product strategy. I think that the Longhorn story is one of steady incremental maturity, up to the point where Longhorn was donated to the CNCF. Our CNCF membership has demonstrated a commitment to driving adoption of the platform and crucially encouraging community innovation. Longhorn is not just about us anymore. Since becoming a CNCF sandbox project around the time of our 0.6 release, Longhorn has made significant stability and performance improvements in a comparatively short period of time. As you can see from this graphic here, Longhorn 1.0 GA has the ability to attach and detach volumes for over 20 volumes per node, and that's reduced from a couple of hours to just a few seconds. That's a massive difference. And similarly, Longhorn 0.6 was only able to scale up to about 40 volumes per node. Now with the GA release, it scales up to 80 volumes per node and beyond. Where does it fit within our stack? I mean, some of you who have been to these meetups before, probably familiar with this picture. We call it the cube cake internally. It consists of two principal layers. And the first one is, I think, a real differentiator for the Rancher story, which is the fact that we treat any certified Kubernetes distribution as a first-class citizen. We won't force a distribution on you. We don't try and lock you in like that. So for sort of data center centric and hybrid environments, we recommend RKE. Rancher's most powerful deploying RKE in those types of environments. And if you're deploying Kubernetes to edge locations, whether it's the thick sort of branch edge or the thin extreme edge, then K3S is a fantastic option as well. And of course, we treat the popular hosted Kubernetes distributions from Amazon and Azure and Google as first-class citizens as well. And sitting on top of that certified distribution support is Rancher itself, doing the multi-cluster management, which consists of three sort of swim lanes, if you like. The first one being simplified cluster operations, where you have this fantastic UI to do all the things that you need to do for day two, day one installation, and also day two management, including monitoring and centralized audit and so forth. And then a really important component is our security and authentication story. It's one of the main sort of attractions of why people come to Rancher. So that's a critical layer, as well as our RBAC capabilities too. And then sitting on top of that, this is really all about encouraging DevOps adoption of the shared tools and services. And as you can see here, Longhorn, as a CNCF sandbox project, sits alongside other very, very popular open source projects like Prometheus and Grafana and so forth, that we kind of build into Rancher and make it as easy as possible for our users to consume. Now, at the 1.0 release, Rancher's integration with Longhorn is pretty good. It's you know, it's similar to Portworx or Storage OS or other partners that we have. But I think going forward, because of its our particular interest in it and our investment in it, we're going to increasingly build more and more integration for Longhorn into Rancher, and we'll be hearing more about the roadmap from Sheng in a second. So Longhorn, why Longhorn for IT ops and developers? Well, there's three principal reasons. The first one is simplified Kubernetes persistent block storage. Longhorn offers a simple one-click deployment process for Rancher to deliver scalable and reliable distributed storage across your downstream Kubernetes clusters that can be managed easily by your developers and DevOps engineers. The second one is intuitive backup and snapshots. With Longhorn, you can easily automate your snapshots and backups to ensure that you're working with the most up-to-date data store in your Kubernetes production environment. And Longhorn also manages all your backups and snapshots in Longhorn's UI, which is free. We don't charge for it, it comes with it. And then lastly, fast recovery. Longhorn simplifies your disaster recovery strategy by replicating your volumes quickly within Longhorn, and you can easily create read-only remote replica volumes in other Kubernetes clusters and define the recover point, RPO, and also the recovery time, the RTO. So there's that. What about technology leaders? Why should business leaders invest in Longhorn? Again, there's three principal reasons. The first is what I've called here cloud native economics. Essentially, the customer doesn't have to spend money on external storage arrays to reduce cost if they use Longhorn. And you know, that's a massive saving right there. But Longhorn is enterprise ready in that it has full support from Rancher Labs, a trusted provider of support services, subscription services around the sort of Rancher ecosystem, and our services are scalable across any environment, however complex, at a very, very sort of competitive price point. So persistent storage everywhere. That refers to Longhorn enables anyone to leverage storage solutions usually reserved for much larger enterprises, because with expensive hardware, it's kind of democratizing access to enterprise-grade software-defined storage. And Longhorn brings cloud-native storage technologies into Kubernetes clusters running anywhere, whether it's on-prem in the cloud or at the edge. And I think crucially, its availability really enhances developer efficiency. Longhorn impacts developer efficiency by equipping them with the ability to manage data repositories seamlessly across multiple Kubernetes environments. And this approach ultimately minimizes the overhead of administering persistent storage for Kubernetes environments and allows development teams to focus just on building applications. It's a crucial benefit. So I'll hand over to William now, who will talk in more detail about how Longhorn and Rancher work together. Shall I continue to run the presentation for you, William?
That would be great. Thank you.
Okay.
Yeah, so much. Can you hear me okay, by the way?
Yeah, absolutely. Yeah, I'll go on mute.
All right. I actually have a battery backup on my router just in case power goes out, to your point earlier, because that's happened a few times in the middle of one of these. So I got about 30 minutes before that we can run without power. So hopefully that will cover us. We'll see though. Okay, so why Longhorn? So, you know, this is kind of one of those obvious questions you ask when you see this product, right? And with any new invention, the question that should be asked always is, what unsolved problem does this address? What problem that we've been trying to address or has not been addressed yet are we solving, and therefore adding to the market, right? And you know, the reality is, the way we see it is, there's a lot of really powerful storage technologies out there. There's some really mature and very you know, powerful, capable technologies that exist out there that have been around for a long time. Enterprise storage, you know, technologies that come to mind. And there's even ones that are more modern, that are focused on cloud native. They're software defined, but they're still very complex. And so what we thought is there's a lot of cases for those really complex, powerful tools, but not everyone needs that power. Not everybody needs basically the Nikon here. So on the right here is an example of a DSLR, an expensive, complex camera. I have one here actually. This is a Nikon D7500. It's a very powerful camera. It can shoot 4K footage, 60 frames a second, extremely, has great optics, but it's heavy. I don't know if you can see how heavy this camera is, but it weighs quite a lot. Now, there's that, or there's my cell phone, which is very light, very easy to carry around. And because it's so light, I end up using it a lot more. They always say the best camera you have is the one on your person in your pocket, or that you have with you. That's the best camera. So therefore, this camera gets a lot more use because it's easier to carry around. It's simple, and doesn't have all of that weight and baggage to it. Now, there's one thing that I do want to express though, because when you hear the term simple, at least for me as an engineer, sometimes I get a little nervous. Like when they say simple, do they mean it's not very sophisticated, or do they mean it's not very useful, or do they mean it's, that doesn't sound good. We actually don't want simple, but as much as we want transparent and straightforward and non-surprising. The principle of least surprise, for instance, right? There's the inventor of Ruby, the Ruby programming language, developed Ruby to be all about developer delight and the principle of least surprise. It should work as you expect. It should be intuitive, and it shouldn't have a lot of surprises. That's more what we're talking about when we say simple. Just like your iPhone, when you take a picture, it just works as you would expect, producing generally a DSLR quality camera photo shot. I mean, if you look at what the iPhone can do now, it really rivals that expensive DSLR. So that's the goal here. And in contrast, it's not this. This is a pinhole camera, very simple. So when if you want to talk simple, let's use this, right? But that's not what we're saying either. So this is the other extreme, which we're is not what we need, most likely. What we're saying is somewhere in between these two, right? There's actually a lot of use case in between these two, is what we found, because not everybody needs the DSLR all the time, but they certainly don't want a pinhole camera either. That's pretty simple. So that's the goal of Longhorn, is to address this market where, and if you could go to the next slide too, the storage admins of today have a lot of responsibilities. And some companies don't have storage admins even. Sometimes they're just DevOps and site reliability engineers who have to manage storage and really provide storage to their users in the Kubernetes world. I used to be one of those. As a DevOps engineer, I had a lot of other responsibilities besides storage. Storage is just one of my concerns. So I need something that works and gets out of the way and doesn't take all of my time to learn because it's so complex, right? And I don't want to be surprised by it. I want it to do what I think it's going to do. Just like when I open the iPhone app, I just want it to take a picture, and I don't want to have to, deal with a lot of complexity. So that's all. That's really the secret sauce of Rancher, or that's what we're trying to add to the market. That's the new invention, among other things, of course. But it's 100% open source. Just some details here. Ease of use is demonstrated by you can actually deploy this with one click in our app catalog. I don't know any other storage technology that can do that. Simple and easy to use, intuitive UI. Its UI is very powerful. There's a user experience first model instead of starting with CLI only. That's very basic, and later we'll get to the UX. We actually started with, let's make the UX great out of the box, kind of like an iPhone maybe. Do you see the resemblance there? Like, let's make the user experience first class instead of the technology, and then the UX comes later. So that's a principle here as well. Data security is really high on the list, and as well as data recovery. So snapshots, point-in-time snapshots, offsite backups, disaster recovery are all out the gate built-in first-class citizens. And it's also a CNCF sandbox project. So you notice I'm wearing my Rancher hat here, and I do work for Rancher Labs, but Rancher Labs is not the owner of the technology. It's the community. It's the CNCF, right? The CNCF is part of the Linux Foundation, the same governance that Linus Torvald is a part of, the creator of Linux, and many other sort of epic open source projects. It's that same lineage of governance that has brought us to where we are today with Linux. That's what owns Longhorn. So we're really excited about that because we get to be a part of it. But really, it's a community project. So next slide, if you don't mind, Tom. Okay, so I want to kind of pique your interest and plant a seed on how you can use Longhorn. Couple use cases. And the cool thing is what we're discovering is we're finding out all these use cases we didn't know existed as we talk to customers. So challenge for all of you on the call today is your homework is to think about how you can use Longhorn and let us know. But an example is in the cloud, in Amazon. Actually, this one surprised me because I didn't think, Longhorn was built for certain goals, to be platform agnostic. We didn't necessarily have a it's for cloud only or it's not for cloud. It's just designed for everything. But I kind of thought EBS would not require, EBS is so good in Amazon, you wouldn't need Longhorn. But I was surprised in that a lot of users have this challenge of EBS, of data locality, the data gravity. And AWS and EBS volume is bound to a specific AZ. All right, so within a region, there's usually 3 AZs, and these are just the buildings that Amazon runs. These are just the data center buildings in that, Virginia or Northern California or Oregon or whatever. And the volumes that have to stay within that building. So if you have a cluster that spans those AZs, which you probably should for redundancy, now your pods, wherever they get scheduled the first time, the pod now has its data bound to it for the life of that pod, for the life of that data, I should say. That data can never leave that AZ. The only way it could ever leave the AZ is if you manually copy it over at a level above. And so for some people, that's a challenge because one, there could be data they need, and if that AZ goes offline, they need another copy somewhere. And two, it also means their clusters start to become lopsided in some ways, because as scheduling events happen, they're being scheduled for many reasons. The data then is stuck there, and there tends to be one zone that gets more data on it than the others. And all of a sudden now, even though you have distribution across your regions or your zones of compute, you're finding that your pods are only able to launch in one place because they need the data there. So it creates this sort of balancing problem over time. So what Longhorn can do is it can replicate the data for you. And we'll go to the next slide in a sec, you'll see that. But essentially it's acting basically just as a simple replication layer of blocks on top of EBS. So it's a great way to solve that problem that you don't have to develop application level solutions for. Okay, and on the right here, this is another one that's really cool, I think. So some of the cloud native storage technologies out there, they require dedicated raw disks. They actually need to have a dedicated raw disk on the server that it's going to use to present storage to this pool of shared storage across the cluster. And so basically it's actually taking over that raw device. That could also be a LUN, it could be an iSCSI target, it could be a few things, right? Because they're VMs sometimes, but it does have to take the whole device. What I love about Longhorn's design is we use sparse files as the backing for our volumes. And this is a Linux technology that goes back decades. It's extremely stable stuff. I mean, for anyone here who is a student of technology and software development, you know that the Linux kernel is some of the most reviewed and inspected code on the planet, right? Because of how many people have looked at it. So you can, there's not a safer place to be than using Linux kernel code in my mind. So we're using sparse files, which means the backing for a volume is a file. So all we need is file system. We don't need dedicated disks. What does that mean? Well, for one, we could actually use the volume, the root volume of the node. We actually don't need a separated disk. And you could also use something alternatively like LVM, which is really powerful because now I can composite disks together. So notice here, we have some VMware VM, and that's just, for example, it's VMware. It doesn't have to be VMware, but just as an example. And then I have maybe like VMware local disk that I've attached to the VM. And then later on, I'm like, I want to add more storage to that, but I don't want to have to deal with resizing that volume and dealing with file system resize. You know what I can do? Add another LUN maybe from my SAN. I have all this excess storage in my SAN, I find out. I just want to attach it to the nodes, and using logical volumes, I can make them span across both of those disks. This is just an LVM tool. It's not a Rancher or Longhorn thing. But because LVM then spans both of those and it presents it as one logical file system, then Longhorn can consume all of that data very easily. It's just writing more sparse files out. So it's really cool how flexible and composable it is, because I don't have to be like, well, I already sized the disks and now I'm gonna have to, unmount that disk and resize it. I could just throw hot online, throw more volumes into it and composite it however I want because it's a file. Really, really a key feature for me is, it leverages a Linux technology instead of trying to reinvent, something much more grandiose that has less flexibility. So yeah, next slide if you don't mind. And I hope there's questions about this. I'm going all over the place, I know, and we really want to hear your questions and hopefully answer them. So another food for thought is DR. This is another challenge that we don't see well solved in the industry. So volumes within Longhorn, within a cluster, are all synchronously replicated, meaning I write a block to volume 1, and then its replicas, maybe it has 2 replicas, just like RAID, the replicas have to sync before it can kind of move on. So that one block gets written, and then it's going to sync over. But the writer is going to be told when the sync completes to make sure the copy's everywhere, because we want crash consistency. Unlike RAID, which has a battery backup unit so that it can back up the cache in case power goes out, we don't have that guarantee in the cloud, so we have to sync everything and make sure the disk commits it on the other side. So that's a good thing. We want that. Do you want that in over the WAN though? Probably not. Does anyone know how fast light can travel on this call? Too bad we can't have audio. This would be fun. We could have a little trivia. Light is limited in how fast it can travel. This is the gate for the internet, right? East to west coast of the US, you're lucky if you're going to get 150 milliseconds. Anything faster than that because of the time it takes light to travel. I mean, it's mainly fiber optics, and then there's switching time, and we're getting better with optical switches, but that's kind of your latency right out the gate. So you don't want that type of latency on all of your volume writes. That's going to be killer for your IO. So in this case, for WAN, you want asynchronous. You actually want the opposite, asynchronous, because I would rather have eventual consistency because it's more important to have performance real time. And so we actually developed 2 modes of Longhorn so that in an asynchronous context for the WAN, you have that ability. And how it works is really just genius. Again, I'm sorry, I'm not trying to say I'm genius. I'm actually bragging about our engineering team when I say that, because it's really clever. We actually use the backup mechanism to do this asynchronous. So let's say you've got a region A and you got a region B. Then you have a backup target somewhere else that both can talk to. Maybe S3, which is kind of a global service, or NFS that you've got. Region A is scheduled with scheduled backup. So you're constantly snapshotting from region A to the backup, maybe every 5 minutes, every hour, whatever you think your data loss tolerance is. And then on the background, region B is shadow copying that data down. It's going to watch the data come in to the volume and say, look, there's a new delta of data. Let me synchronize that in the background. So now you have a pre-warmed disaster recovery volume sitting on the other side of the country, on the other side of the planet, wherever your backup site is. Really cool. And you don't need any special technology. You don't need, you don't need a global coordinator or something, or some, complex replication manager that has to be deployed, or specialized hardware. You need S3. I mean, does it get more accessible than that, or NFS? I mean, everyone pretty much can find those one of those things usually. Has been my experience, and love the feedback if you guys see differently. So so that's the use case for DR. What is our next slide? I'm sorry, I'm forgetting. Oh, this one. This is a good one. Okay, so we're almost done with my part, and we're going to get into the fun stuff. So just if you could just kind of toggle through this one, Tom. I think we just want to show what I was talking about with that HA across HA flow across zones that Longhorn on top of EBS can provide. So currently, without Longhorn, EBS is bound to one zone. That's what the red was. With Longhorn, you can see how Longhorn is acting as basically just a translation layer on top and a replica. So kind of a cool use case we were informed about from working with the great community people like yourself. So so I think that might be it for me. right? Because we already did the DR one.
Yes, it is. Yeah. So I'm going to hand over to Sheng. There are a few questions, but I think I'll probably wait until after the demo. So Sheng, shall I hand over to you?
Sounds good.
Wow.
Yeah. So let me change to. Wow, it's a long list.
It's a long list. Sorry, I was just was taking some time. There we go. Have you got control now?
Oh, yes. All right, so can everybody see my screen?
Yep.
Okay, so here I'm going to give a demo of Longhorn, and if you have seen the Longhorn demo before, this demo is going to be fairly like straightforward, but going to show you a few important perspectives of Longhorn. So what you see here, in fact, of course, is Rancher, and you can see that we have 3 clusters here. One of us using for my development on Longhorn, another 2 is for the demo purpose. So when you're looking at the demo one, we have nothing stored, and also we don't have Longhorn installed as well. You can see the workload is empty. So now the first thing I'm going to do to show you guys is to install Longhorn. So how easy it is, just click the apps, click the launch, click Longhorn. And you can see the latest version in the 1.0, and by default for the demo purpose, we don't change anything, and we just click launch. So now, as William mentioned before,
Sorry, Sheng, just to interrupt you, is there any way of maximizing your screen there? There's, at least for me, I'm seeing a big margin at the top there. There we go. Great. Fantastic.
Oh, okay. All right.
But now it looks like it's maybe what you had before. It's gone maximized and I can't see the full thing now. That's just me.
Okay.
That's better. Lovely. Okay. Sorry for interrupting. Great.
Okay, no problem. All right, so yeah, so by the default, for default configuration, Longhorn is going to use your root disk for the storage, and for the production environment, it's not really recommended because we still think it's better to isolate your data from your root disk to prevent like extra like disk pressure for your Kubernetes cluster. But for the demo purpose, this is the easy way to install, and also. And if you have enough space on the root disk and you want to use it, this is the way to go. So now we're seeing that Longhorn system is being installed right now, and the app is coming up, and then you just click this URL and you check, and you can see the Longhorn UI here. It's fairly straightforward. The first is you show the dashboard, and you can see in the left side we have no volume yet. And also in the middle, you'll see that what's the storage available to the Longhorn. And in fact, this, as I said, is from the root disk of your nodes. And of course, it's customizable. And on the right side, you can see that we have 3 nodes. Everybody is healthy right now. On the node page is in fact the place that you can customize your node and customize your disk. And if you want to add more disk or add labels to the node, which is the way to schedule volumes, and you can do it here. And also you can add labels to disk and make sure that the volume is scheduled to the certain disk. And you can add more disk if you want. And just to provide the mount paths on the host for those disks. So, and also you can do that through the Kubernetes load labels annotation as well. We have that document in our docs.longhorn.io. So, and for the volume side, of course, there's nothing showing here. On the backup is what we called our backup incremental backup mechanism. We call this backup store here, but we haven't configured that yet. So that's you configure that first. So getting the settings and find the backup target. And this one is, in fact, we are configuring to the S3, and we're supporting NFS and S3 endpoint at this point. So it's that happen to be like, doesn't need to be S3. It can be like Amino, any S3 compatible API gateways. That's it. That would be fine. So now you can see that there's a bunch of backups showing up, and you can find more and click into details just if you want to see more about them. So let's go back to using how can I use Longhorn. So it's still also very simple to show this. I'm going to start a WordPress and using Longhorn. And one thing about this demo is I always have to make sure that password is right. Otherwise, later I cannot even log in. So let me carefully type in the password. and enable the persistent volume for both WordPress and MariaDB. And make sure Longhorn is using a storage class and click launch. So this is the way of using Longhorn. So basically, in the end, Longhorn is creating a storage class in your Kubernetes cluster, and of course, you're welcome to create more storage class with different parameters like replica count or other like backup or labels. But for the default storage class is going to be used for our demo purpose. So you can see now Longhorn has created 2 volumes, the dashboard has been upgraded, and also the Longhorn volume list has shown 2 volumes. So you can also see that those 2 volumes, even the name is really complex, you don't really know who is who. But when you take a look at the attached to, and you can see that this volume is attached to the MariaDB on this stateful set, and what's the pod name, and this volume is attached to the WordPress. So in fact, Longhorn is open source project, and the way we got these ideas to help user to identify the workload and the PV and the PVC, those are really coming from the user suggestions. And we found it's really helpful for us as for the Longhorn, the project to get better user experience. So you can see that. So also, and when you click into the detail of the volume, you will see that this volume is currently healthy and attached to the node, and the front end is block device, and that's the most common front end you're going to use for the Kubernetes. And the attached node, this volume is currently attached to the demo2 node, and it's exposed as this block device on the node. And also you can see the nominal size and actual size was the volume taking space on the node, because the format is 64 by default, they are going to take some space. And also you can see other information down here. On the right side, you can see this volume in fact has 3 replicas. That means the data of this volume has been replicated on 3 different places. This is working like a RAID 1. So as long as you have at least 1 replica healthy, and 1 replica like still working, and you still have the access to your volume. Even like your old Kubernetes like cluster went down, and you only have the hard drive, and here this is the place we store the data in Longhorn. And as long as you have the data in this directory intact, you can easily recover the volume from this. So that is another advantage of Longhorn, that is we really have building multiple layers of protection for your data, and make sure that you should never lose your data. So down here we have snapshot, and we can easily take snapshot, and the snapshot is the taking inside the cluster, and we can also create a backup. So the backup is in fact a taking snapshot and make the backup that snapshot, as you see the progress here, to the S3, which we just set up before in our backup store. So this is convenient, but in fact the more convenient way is you can also set up recurring snapshot and backup. For example, I'm going to, for the demo purpose, I'm going to set up recurring backup every minute. We're going to take a backup for once per minute and return the last 3 of this backup. So I click save, and the backup should be on the way. And I'm going to do the same for and also you can see that we highly recommend you have a recurring snapshot backup schedule. And when you have the schedule, you will see this icon lit up. And if not, we can add new backup here. Return the last 4. Save. Yes. So now the data of these volumes, we're going to back up to the S3 on the schedule, and you don't need to worry about like losing your data on the disk now. So at least whatever backup is already being shipped to the S3 or somewhere external to this Kubernetes cluster, and you won't, as long as you don't lose that cluster, you don't lose that backup store with your cluster, you're fine. So this is the one thing we have building, and the backup is of course incremental. And this is one thing we're building to also distinguish from other storage solutions like SAF. So SAF is mostly, they provide the in-cluster snapshot, but they don't have mechanism to ship the backup outside. So if the cluster goes down or something corrupted on the SAF itself, you are really kind of screwed at this moment. We can talk about more the difference with the Longhorn and SAF later. SAF later. So let's take a look at WordPress. Okay, WordPress is up. So let me see if I set my password right. Come on. Okay, password is right. Okay, so let's just create new online meetup demo. Publish. Yes, repost. Okay, so this is this data of this post has been stored in the Longhorn, and of course you don't need to take my word for it, but we can show it later. So there's one feature in Longhorn that is also stands out among the others is the disaster recovery. And by disaster recovery, what we mean is if you have a main cluster which is perform the majority of data and workload, and then you have a and what if you want to have your like workload switch to the backup cluster when everything like something in the main cluster is down? So in order to do that, the cluster, the application itself, like the WordPress here, is very easy to deal with because this is stateless. But how about your state? What about your data in this cluster? So as William mentioned, this is the DR volume mechanism we're building. And what we are going to do now is we are going to head over to the second cluster, which is totally in the, well, it's still in the DigitalOcean, but a totally different Kubernetes cluster. So then the second cluster will already have Longhorn installed, and we just take a look at this Longhorn, and you can see that this Longhorn on the second cluster doesn't really have any volume yet, right? So, but they're pointing to the same backup store, and we're using this incremental, we're going to implement this incremental restore for the DR volume to restore the data from the first cluster to the second cluster. You can also think about this as asynchronized replication from first cluster to the second cluster. So let's do that. So in the backup tab, we are going to see, okay, those are two volumes we just created before. How can we know? Because when you click into the details, you will see the workload and the part, those information are there. And then I can create DR volume. And in fact, let me create in this page. That would be easier. I just create DR volume for post. And I set is replicas 3, of course. And then you can see that this volume has been created. But you can also see there's one thing is we of course this volume has been created newly on this cluster, but it's also have the configuration, also have the knowledge from the old cluster. As you can see that the WordPress was used before, and also it was attached the MariaDB, and this one is attached to the WordPress before, right? So this information has been maintained. So yes, so of course, because this volume is currently, this indicates this volume is not usable right now because it's being incrementally restored, and any data writing in the old block should be shipped here. So let's write something here. Let's see. Okay, so this post is live. Okay, so this one you can see that is original volume. You can see this volume has been used, and this one is the new Longhorn volume inside the new cluster. Let's wait a while for the data to be shipped in, and you can see that. Okay, so the last backup is being backup for a few minutes. So now I can like just wait for the next cycle, just be safe. So any questions? I can answer a few questions.
Yeah. Sheng, there's loads of questions. So should we take sort of 5 questions and then move on with the rest of the demo? Does that make sense?
Yes.
Yeah. Okay. One question is it possible to compare Longhorn to Rook with Ceph?
Yes. So in fact, Ceph is the one project also inspired Longhorn. So we see that Ceph is really mature, has been there for a very long time, has spent a lot of effort. But the one thing we saw Ceph is, so it's very stable. And but the thing is, by design, Ceph is complex. So for example, if you're looking to that how to configure your crash map, correctly according to your setup, that causes a lot of trouble for many users. And if you search for at the internet, search for like stories on how Ceph cluster failed, something like, the crash map was configured wrong, and somehow I put the two stripe of the same volume into the same disk, and that disk down, and everything's gone. So that's kind of things you make us realize, yes, Ceph is very great. It's great as the software-defined storage solution, and also it's being very active. But the thing is, by design, Ceph is pretty complex, and also Ceph doesn't have the ability to ship the backup outside the cluster of those. So that means that you are on your own, or you have your third-party things to work with Ceph to get this part down. So in Longhorn, we are trying to provide a much simplified and straightforward user experience compared to Ceph. You don't need to worry about like having the two replicas scheduled on the same disk or scheduled on the same node and those kind of problems, and make sure no node or no disk down, we're going to corrupt all your data. So this will be done just guaranteed automatically based on the design of Longhorn. And also you can see this mechanism, in fact, is very transparent. When you have one replica, you can just even use that one replica to recover your whole volume. So it's always a way to recover. So even something went wrong. And also the Rook, a little bit more about the Rook is built on Ceph and to make Ceph more compatible with Kubernetes. But Longhorn, in fact, is just born to be Kubernetes native. We're right in the way of the cloud native. Every orchestration things we don't use actual layers of things, but everything when we design Longhorn, our mindset is a container and the microservices, and that is Kubernetes native. That's also how we take Kubernetes advantage to implement all the system with relatively like small amount of code. So that is really some of the difference between the Longhorn and the Ceph. In fact, yeah.
I was just going to say, and I think I think Rook Ceph is a really it's a great stable technology, and it's powerful. So one way you're comparing the two is like, is there things you need though that Rook Ceph that Rook Ceph will do for you? Because otherwise it's that camera again. It's that big Nikon, this thing you're going to be putting in your pocket, on your bike trip, along the river. And do you want to do that? Do you need to? We're hoping that we can actually get all of the key features that are needed in a much simpler and much more understandable way. That's our goal.
That's a really nice comparison. Maybe
Tom. In fact, I'm close to finish my demo. Just let me.
Okay, let's do that. There's loads of questions, so
right.
Definitely will. Yeah, no worries.
Okay, so I'm going to activate DR volumes, and so that's we have waited for a long time, right? So we're supposed to already should able to have the volumes, like whatever contents we write into the main cluster, write it down here. So I'm going to create PV and PVC for both of them. And that is something you can do with Kubernetes, and hopefully we are going to apply those steps once we have the application backup restore feature implemented. So now this is demo 2, right? So the demo 2 should already have the things available, and let's go back and launch the WordPress on demo 2 and see if we have the same data really shipped over. And now I need to select the existing persistent volume plane, and that is what we just created. And also for the MariaDB, yes. And one thing you probably noticed that for a stable set, for the MariaDB, it doesn't have the choice to give you to say what's supposed to be the existing PVC, because MariaDB is working as a stable set, and for the stable set, the name of PVC is predefined. So that also shows that if Longhorn doesn't remember the name, in fact, what's the name? Name is data WordPress MariaDB-0. If Longhorn doesn't remember the name, and then the user, whoever orchestrates this restore, need to remember the name, that will be a little bit tedious work to do. And let's see. So now you can see on the Longhorn, this is on the second demo 2 cluster, this backup cluster. The two volumes has been attached, and now WordPress is going up. And let's see if we can get the same thing as we are writing into this DR test. This is the first WordPress. Okay, that's probably, I can answer one question here, I think. Yeah, let's wait for the WordPress to be up.
Great demo. Very, very bold of you to do that live. I'm always impressed, Shane.
Yeah, next time we want to do something even more bold, and that's
That's how we live. We like to live on the edge here with demos.
Before we go on to, I mean, how finished are you? You done now? You want to show something?
No, just
waiting for that to come up.
Let me.
And actually, I just want to point out one thing that's kind of really obvious here. I don't know if you just noticed this, but Sheng in the course of this meetup has just deployed an entire storage solution. I don't know if anyone here has ever done this themselves with other technologies. I certainly have. Don't need to name any technology names, but I've never done it that fast. So, just one thing to kind of, point out here is like, this is why we think it's so distinct. I mean, this is kind of radical in storage.
Let's see. Oh, okay. So just make sure I'm not cheating here. Demo 2, there's a different cluster. Default, this is newly installed WordPress, and let's take a look at this WordPress data's here. So that's proof that the data has been transferred from synchronized, replicated asynchronously from the main cluster to here. All right, so I think that concludes my demo. So should we go through the
roadmap? I was thinking.
Yeah.
Do you want to hand? Yeah. Do you want to hand back control to me so I can show the slide?
Yes.
Or yeah.
I don't. This is really very long list. Okay, so yeah. We're talking about a list of changing presentation. All right. Yeah. So I think Tom will give you the.
Yeah, I'm just trying to make sure that I got the right screen. Okay. Well, let's hope it's that one. Yes. Great. Okay. Can you see that?
Oh yes.
Do you want to talk us through that?
Yes. So I'm just quickly go through the roadmap, and probably you're familiar with the Rancher or like many open source projects. The roadmap here is a guide, not really set in stone until it's like we're very about a couple months before. So for the next few things we want to do on the Longhorn 1.1, we want to improve on our performance, and also we want to do the application backup and restore. And in fact, we are also talking about on the 1.2, where I want to utilize SVGK to have a better performance on our front end part, which is the part that we expose the block device, and provide performance metrics, including premises support and the CSI snapshot support and Longhorn CLI. And for the future releases, currently we are planning on have the quality of service, which is going to depend on SVK, and the data locality, which is in fact many people asked about, is that can Longhorn controller like engine only be running on the node that has a replica? The answer is no. Now the Longhorn controller, the Longhorn engine can connect to any replica in the remote through the network. But we're also looking at if we want to have a data locality, just means that always have a replica locally and do the synchronization. That's probably going to improve the fault tolerance and the performance of the data flow as well. And we are also looking at the backup encryption, volume encryption, alert notification, and the sharding across different disks, ARM support. And many people asking about ARM, but sadly, unfortunately, we haven't got much time to work on that yet. And also dedicated Longhorn cluster, instead of like currently hybrid coverage, the way of support. And for the latest roadmap, you can take a look at github.com/longhorn/longhorn and the wiki. and we have always up-to-date roadmap there. And also you can follow the Longhorn development on the Longhorn/Longhorn on GitHub. Yeah.
That's cool. Right. So Q&A. There are lots and lots of questions here. So I'm going to sort of start off with some ones that I saw come in a while ago. This one's about AKS and EKS. How does Longhorn behave with AKS, EKS node autoscalers? When the new node is provisioned and later decommissioned, will it have an impact on data consistency or performance?
Okay, so currently, this is one problem we discussed recently, that, for example, the EKS autoscaler, and the user can have a node commissioned and decommissioned, but persist the volume as long as you have external volume attached to that. So currently, Longhorn user need to manually recover from that, say, because you have currently in the Longhorn itself, the disk is tied to the node. But in the next 1.1 release, and I didn't mention the roadmap because it's more like refactoring, but we are going to support autoscaler and make sure we are going to decouple the disk from the node. So whenever you have the like instance commission or decommission, and we are going to reflect that automatically in the Longhorn. So that is coming feature. Okay,
cool. Right, so this one's from David Larsson. I know it's in the documentation, but could you expand on the disaster scenario? What are some common scenarios if a volume is disconnected? What would happen to the application? Will the volume be reconnected? How long will it take, etc., etc.? I think he just wants a bit more detail. William,
okay,
do you want to take that one?
Yeah, this is going to be very big topic. So in short, for Longhorn, we're always going to try to disconnect, reconnect back when you have a node disconnected or workload disconnected. But it also depends on how is this like node disconnected. For example, in one sense that if your workload crashed by itself and the Longhorn volume didn't detach by itself, that everything should be fine because the workload is going to restart and everything is good. So if you have something like a network situation, like a network intermediate interruption or some CPU situation on the workload you are working, and the Longhorn engine probably cannot properly communicate to the other replicas, and that can result in the volume faulted, but we are going to reattach that volume to the workload whenever workload still start running. So there's the one part of the document. We said we have a point that if you are using ext4 file system, we can automatically do the reattach and the remount to recover from this kind of situation if your network is not stable. So that is inside our documentation. And also another situation, in fact, is the problem from Kubernetes. So currently, Kubernetes, because Longhorn is a read-write-once type of storage, it's block storage, it's just like EBS. So if the Kubernetes has one node down, and the next node has workload, let's have two scenarios. If you are using deployment, which is not really that friendly for the read-write-once storage, and that part goes down, and Kubernetes, we are going to spin up another part, and the Longhorn, but currently, Kubernetes will not going to tell Longhorn to detach from the first node, but in the 1.0 release, we have put in a fix for that, just basically compensate for the Kubernetes because the Kubernetes upstream doesn't have a fix for this kind of situation yet. We are going to automatically detach from the original down node and migrate our volumes to the new node and attach to the workload to make sure your workload is still working fine. But if you are using a stateful set, so Kubernetes has another limitation that because stateful set identity is stable, they are not going to recreate a new pod for the stateful set pod. So you have to delete that pod first. So in this scenario, Longhorn will still, currently in the 1.0 release, Longhorn will still expect the user to delete that pod first, and Longhorn will always ensure that the volume will be attached to the new pod and the new node correctly. But the thing is, we also feel that it's not enough for the user. So in the 1.1 release, we are going to introduce a new feature, and we to automatically either delete a node or delete the pod. We haven't decided the approach yet, But make sure that whenever you have a stateful set and with one pod down, and you can give Longhorn privilege to do that, to recover that pod if you want. Then we are going to do something to make sure that Kubernetes is going to spin up that pod, stateful set pod in another node, and with Longhorn warning attached to it to resume your workload. Yeah, I think there are probably even more on that, but we can talk about offline.
Yeah, it's a pretty comprehensive answer, though. Thank you for that. Right, so I quite like this question. I'm running databases per Kona cluster on Kubernetes on local host path mounts. Is it possible to use Longhorn volumes and backup options together with local host path volumes, or is there an integration of local host path planned?
Okay, so in fact, if you want to provision local volume dynamically, I also have another project called the local path provisioner, and that's why it's in fact currently we're using host path, and we're also looking to the local volume to see that if that's going to make life easier things. But that provisioner, we're going to dynamically provision a volume that's bounded to the node you specified, that which is basically the workload is running. So for the Longhorn, it's like a more slightly different approach, because the Longhorn is targeting at enterprise grade high availability. So we have multiple replicas, and we are using the storage on the node to provide storage for this replica, and we are going to ensure that no matter what happens, like at least as long as you have one replica still, like the node at one replica still running, we are going to make sure that you can have that volume attached and used by your workload. So, but in the case of using local volume or local path provisioner, and of course, the local path is definitely going to be performance much better, right? Because it's like real hard drive, and you just have direct access to it without the layers on top of that. But the thing is, if you lost a node, like this node has been decommissioned, and you are going to lose all your data. So of course, if there is acceptable on the database level, say the database or your application have replication mechanism by its own, it's totally fine. But if you are not satisfied with that, you want to have backup solution, you can also run Longhorn with the replica count as 1, and that is going to provide you the incremental backup and the advantage from Longhorn, but still like allow you to take your space efficient as few space for your volume as few as possible.
Okay, cool. This is a great question. How do you prevent split brain scenario?
Okay, so for the Longhorn, currently we don't have a split brain scenario because we don't have a quorum mechanism. So for the controller, treat every replicas equally, and the replication, as we mentioned before, is synchronized. So basically, that means that we are make sure that every write goes through the block device, goes into every replica, and we'll wait for every replica to either respond or not respond or report the error, and then respond to the user. Of course, if the replica doesn't respond or report the error, we're going to cut that replica and try to see if we want to start rebuilding another replica. So we are not going to have split brain issue at the moment. And later, we are going to implement the data locality, and we're still going to only have like one replica as our master replica. So it's still not going to have a split brain scenarios.
Okie dokie. Oh, here's one comparing to other technologies. How does Longhorn's performance compare to Portworx now and in the future? I mean, I'm not sure. Well, I suppose we can answer the first part of that question. Portworx performance comparison.
Yeah, I have to say that Portworx is faster. That's they have a kernel driver, and they have done a lot of great job on the performance side. At the moment, they're faster. But for a Longhorn perspective, our architecture is pretty simple and straightforward. Just as you can see that really you cannot get it faster if you're just looking at architecture size. You cannot get it faster by directly writing, like faster than directly writing file to disk. So of course there are going to be latencies and the cache and things. They're going to place in the factor here. But in fact, currently Longhorn's performance is comparable and probably slightly better and safe. And we are still, but the things is we're still looking at performance, and we are going to have pretty good, I think, pretty good performance gain in the near future. So that is why I mentioned about that revision counters and also the SPDK, the front end, all those stuff. So optimization is on the way. So, but now we feel like the performance of Longhorn is adequate because, well, so many people are using Ceph in the production.
Yeah, cool. Okay. There's loads and loads of questions. I hope we have time to go through all of them. This one is from Martin Borgman. Is Longhorn supported on Azure? Azure has Azure block storage and currently does not support NFS with Azure files, I guess that is.
Oh, okay. So I do remember that there's one colleague of mine has mentioned this. We currently don't support Azure as it is. You can use Azure Blob and like some S3 gateway to that, but this is enhancement like ticket in the GitHub right now to talk about this.
Okie dokes. Easy one here. Is there a version requirement for Rancher to deploy Longhorn?
Not really. I would say 2.3, 2.4. Of course, it's better to use the 2.4. I think it was the latest version, 2.4.
2.4 something. Yeah, I can't remember.
Yeah, 2.4 something. So the latest version we have fixed a bunch of things like integrate with Longhorn, but those issues can be worked around by using kube control stuff. So that's but in the future, the next release we are planning to have a better integration with the Rancher. But of course, as you see that Rancher is one part, but Longhorn is a CNCF project. So we're always going to still have to. In fact, we're very happy to also accommodate other users who is not using Rancher.
Yeah, right. Absolutely. Another easy one. We'll try and get through some of the easy ones. Because we've got so many. How does Longhorn provide an API like Rancher for automation, or does Longhorn provide an API like Rancher for automation? Is the question from Justin.
Yeah, so currently Longhorn of course has the API layers, but currently the client we don't have a CLI, and we have a Python client, and we're using that for testing and scripting stuff. And I have to admit it's not very straightforward to use, but the many things you can do is, for example, if you want to customize on the node level, you can use the Kubernetes node labels and the annotation stuff to customize the node and the setup the disk. But many other tasks, I admit that we still need to have better support for the external APIs. And the most API I'm talking about is through the Longhorn Manager, which is the UI talking with the Longhorn Manager using the Longhorn API and that part. So yeah, so we still need to like more improvement than that. And also, I think their users there's some third part like some open source users have developed some CLI tools for Longhorn to manage the node stuff. And mine was taking a look at the GitHub, our GitHub repo.
Okay, cool. Here's one from Josh. Can we increase performance by stripping replicas similar to RAID 10?
The replicas, in fact, is on the read side, we already have like round robin. Like for example, if you think about if you measure performance against one replica versus 3 replicas, the read performance is getting better. Of course, the write performance is getting worse, right? Because you are going to like write in 3 different places. But in the read performance, because every time when we do the reading and we are going to read one of the replicas, we don't need to request for all of them. So that is like similar to like what the stripping is doing, and that is also increasing our performance. So currently we don't want to do stripping, in fact, because if we do stripping, it's going to be like we need a consistent crash map, and need to probably get something like more similar to Ceph, which of course is not a bad thing, but it's seems like too complex. And
I want to point out one distinction here, which that makes this kind of analogy not as equal, which is in RAID, you have a battery backup unit that provides the cache so that you can write without having to worry if the disk got it or not. And then the BBU can figure out writing to all those stripes. we don't have BBUs though in the cloud. We don't have battery backup like that. That's part of what the cloud changes, is you give up some of those hardware level features. And if any of you have had to manage battery backup, you know, they're a pain in the butt when they die in the data center. You have to go find them and dispose of them and all that. So maybe better we don't have them anymore. But it is nice to remember. So that's a big reason that the economics are different here. So striping doesn't give you the same thing.
Okie dokes. One here. Can we expand volume without any downtime? If yes, can you share the steps? That's from Guru.
Okay, so currently we haven't able to support that. So we can expand volume with downtime, but we cannot expand volume without downtime. So we're still working on that.
Okie dokes. Right, simple question here. Does Longhorn deploy to every worker node by default?
Yes.
Okay.
So in fact, one thing more clarifying on this. So it doesn't matter if the workload is going to provide storage for Longhorn to use or not, or just as the consumer. So Longhorn have a two part, and the replicas is going to be used, and whoever on the node that provides storage to Longhorn, but the engine part is going to need to be run on the node that workload is going to running on top of. So because in Kubernetes, workload pod can run on any workers, so Longhorn need to be deploy on every workers.
Okay. Cool.
Great
Can you increase volume size? Yeah, they are. Can you increase volume size once the PV is assigned? That's from Thomas.
Yes, so that is as just we answered before, that is the volume expansion, and we support is do that from Longhorn UI and also through the CLI volume expansion plugin, and that part is down. So but we don't support online volume expansion now. We only support offline. Means you need to take the workload offline before you extend the volume.
Okay. Sorry. Is it possible to mount the same on volume? Sorry, this is sick, right? So it's just typing. Is it possible to mount the same on volume on multiple pods on different nodes? Does that make sense?
Okay, yes. So no, currently no, because Longhorn is a block storage. So you know that block storage is fairly common limitation that you only have this block storage provided to one node. It's not like NFS or EFS. So that's this distributed file system. The reason is if you change the block storage without the file system on top of the knowing, the file system might think the block storage is corrupted. So that's why for this Longhorn is considered read write once storage, but we're working on that. The way we're working on that is we try to set up a enterprise grade active backup setup, and we're not going to have anything written in the backup until the master failed. And that's in that way, we can, on top of that, we can put something like an NFS server or some distributed file system and provide the service to the user at the same time, like just have the high availability of the storage. And for example, if you're running an NFS server and that node on the server running is down or gone, you're going to lose your data. But with Longhorn backing up the NFS server, and that's not going to happen.
Okay, cool. Right, when using LVM, if the partition is extended, is there anything that needs to happen in Longhorn?
No, the Longhorn will recognize it automatically. Of course, you need to expand the file system as well, but Longhorn will going to recognize the disk change, the size change automatically. Awesome.
Question from Lou. Can Longhorn be used in conjunction with other services that require storage, for example, Redis memcached? I assume we could just bind those services directly to a Longhorn volume. Is it recommended?
Yes. Yeah, they're just standard persistent volumes, and because we just provide storage class, you can provision any persistent volume with that storage class, and that's going to be backed by Longhorn.
Nice. Okay. Question from Taran. I hope I pronounced your name correctly, Taran. Do we have to pre-provision the storage to form a storage pool? The context being a Kubernetes worker node pool.
Sorry, I don't quite. I probably need some clarification. So for the Longhorn itself, as I demoed, we can just use the root disk, but we recommend you to have a separate disk on the node. So just to make sure that it's not going to interfere with the Kubernetes or whoever the main running system is. But we don't, at least in Longhorn, we don't really have a concept of the storage pool and the right. Yeah. So if we can get more clarification on the question, I can answer them better.
Okay. Well, Taryn, if you want to clarify, that'd be great. So a couple have just come in from Jose. The first one is we can think of a WordPress running in Kubernetes with auto-scaling failover without the pain of NFS or other alternate solution for the stateful app. Is that a question? Maybe not. No, maybe this is a better one. Sorry about that, Jose. It didn't really parse. How does Longhorn compare to DRDB? Is it like DRDB plus Kubernetes integration?
DRD.
I think that's the kernel block replicator. I think didn't you use that one?
I think I heard about them, and before that's DRBD, and also there's I think the latest version they call Lindstorm, and they also have something similar to Longhorn coming up. And well, I think we're targeting the same league, and we're providing for block storage. Yeah, I would say it's fairly similar, but we're not depending on the technology-wise. It's probably going to be pretty different.
I mean, the way I try to understand it, Shane, correct me if I'm wrong. When the block gets submitted to the scheduler, to the Linux block scheduler, whose job it is to then make sure that the disk gets it and get the thumbs up. Basically, there's something there happening that says, "Oh, here's a block. Let me take a copy of that while you write that, and then I'm going to go synchronize it over here," which is kind of how DRBD works as well.
All righty. Right. So next one. Can you automatically grow /var/lib/longhorn by adding an EBS or some other block device? That way, if someone asks for a 200 gig volume, I don't have to. This is all sick. I don't have to do that much on the nodes beforehand. Does that make sense?
Okay, I see. Okay, so currently we don't support that, but that is a good feature. Like if you give Longhorn the credential to your whoever provisioning your storage, and Longhorn do that automatically. Yes, we can consider that as a feature, and feel free to file a enhancement ticket on GitHub, and we can look into it.
I can't tell though if he's saying automatically do it or if just he could do it later. So there's two. There's two. So if it's the first one that Sheng said, that could be a feature request, which I think would be cool. But right now, like I showed in my LVM slide, you could use LVM, for instance, to be the logical volume mapper on top of n number of volumes, and you can just online keep adding EBS volumes to that pool in LVM, no problem.
He says automatically, so I don't need to LVM extend, is what he said. That's Greg.
Okay.
Okay.
Yeah.
Feel free. I gotta listen.
Yeah, no worries. So this question from Christoph John. I'd like to come back to the Percona database related question. How does the read-write performance of a local volume compare to the solution you mentioned? Hence, to use a Longhorn volume with a single copy.
Of course, the Longhorn still have a pretty big overhead over the local volumes, and if the performance is critical at this moment, I would still suggest if your applications have the reliable replication mechanisms across different volumes, then that will be your first choice. But the thing is, on Longhorn, of course, we are targeting have eliminated difference and increased performance of Longhorn. There's many things we have in plan to do that.
And you probably want to read this book too. This is written by the Percona guys.
How do you get?
Then you'll get the best results out of your storage, whatever you use.
Next question from Dinant. How is the performance going on the worker nodes? Will it decrease when more containers arise, in brackets thousands, and use PVs?
Of course, you will decrease if many people write into the disk at the same time, right? So it's going to be like law of physics too. Yeah. So but I will say that you can. I think the one thing is you need to see the measure, like if everybody's busy writing, or you are just having say a few of the busy writers and not just occasional writers, how many nodes you can, how many volumes you can have comfortably on the node, or do you need to like increase the memory of the CPU? That's going to have some trickling and try and errors to figure that out.
Okay. Another question from David Larson. Is there a nice way to pull in production data to a stage/accept environment continuously through Longhorn, so each review app or stage app has actual production data?
DR volume can do that, but DR volume you can, once you activate the DR volume, and they are basically disconnect from the upstream. And also you can, if you want to say don't activate DR volume, or you can have like a backup putting into your backup cluster or testing cluster from the production data as well. And that one can give you that one won't be incremental, so maybe the restore is going to take a while, but that one is so you can freely use it after you restore it. So on the DR volume side, which I mentioned, incremental restore, that is set on the premises that you can you need to leave the DR volume there, and it's not going to be operational by the workload, because you have to make sure that data is consistent with whatever you receive from upstream.
All right, cool. Right, here we go. This one is from Andreas. Is the backup function doing incrementals, or do you have some kind of deduplication feature implemented?
Yeah, so the backup is also doing incremental and dedupe inside the volume level.
Okay. Does Longhorn backup only the volume or also the application and the data? That's some dimmers.
So currently, our target you have the application backup and restore in the coming couple of releases, but currently Longhorn have part of the application data, as you see in my demo. The PVC name, the previous workload name, those are like maintained, and but now you need to have those metadata. You have this metadata in the Longhorn, but now you still need to like manually create application and use the Longhorn volume to use it. So for the application backup restore, we really want to have the experience that you can just backup, say, I want to backup this application, like this namespace or this few parts, and then everything associated will be backing up, and the Longhorn are always going to be find the related backup if you want to do the restoration and kind of starting the application along with it. So that's our goal for this application backup restore feature. But even now, we do have some metadata as you can see from my demo as embedded in Longhorn.
Yeah, okay. If you want to deploy to a separate disk, do you first create an FS mount to var lib Longhorn and then deploy, or is it customizable during the deployment via Helm?
You can choose to mount it to any other path on the node. Is that it have to be in fact it definitely doesn't need to be in the var lib Longhorn.
Okay. And question from Courtney again. If a pod is running on a node, can it access Longhorn storage from another node?
Oh, yes.
Okay. Right. So we're sort of plowing through these questions now. We've got maybe 4 or 5 left, unless there's any more. What latency does this presumably Longhorn add to normal I/O? That's from Wesley.
Yeah, that's going to depends on what's your reading or writing block size and the performance. Yeah, so I don't have the number out of my hand. I think there are a few performance metrics like done by the users, and you can search for like Longhorn performance. And I think there's one by our users, and they show the performance of Longhorn and the latency stuff.
Okay, cool. This question from Michael Lechner. Is there a way to use Longhorn for an application which needs shared file system between pods?
As I mentioned before, the Longhorn is read-write one storage. So if all your pods on the same node, that will be fine. But if you pods on different node, we're still working on a solution for that. As mentioned, that just have an enterprise grade and read-write many solution coming out in the next couple of releases.
Okay, cool. This question's come up a few times actually. I've answered it by text. Can I deploy Longhorn on top of Kubernetes without using Rancher? That's from Amit, but it's been asked a number of times.
You can deploy Longhorn using YAML file or Helm chart.
Yeah, right. Okay. Right. So here we go. This is from Gilbert. He says some folks are testing Longhorn. Say mounting and attaching volumes is very slow. What are you doing to improve the performance of mounting and attaching volumes to pods? So we talked about that earlier on.
In fact, that's a very interesting question, because currently the mounting and the and the previous version, Longhorn indeed have, for example, before. So this is like gradual increment, improvement on the performance. So before I think before the 6.0, the mounting, the attaching and the detaching is going to be slow, because every time we're going to create pod for that. And on the 0.6, and the speed has been increased, but if you have like more than 40 volumes per node, they're going to be slowed down to crawl. But and later we increased performance again on the mounting detach and attach and detach. Now, as you can see, that it should only take like less than 5 seconds or even like 3 seconds to do those operations. So should be fine right now. And if you hit some specific issues in like 1.0 release, feel free to raise the issue on GitHub.
Right. Yeah. So it's likely they're probably using an earlier version, right? Is that what you think? Probably.
Yeah.
Yeah. Okay. So this question from Stephen Thompson. What is the best process to reboot a worker node hosting Longhorn volumes? For example, 1 worker node in a 3 worker node cluster.
Yeah, so normally we suggest that if you, so this is one thing we still want to improve, but currently if you reboot the worker node, and it's better if you can just like move the replica from that node to another node, and that's going to trigger the rebuild process. In production, we have a best practice that you can disable the node scheduling and reboot the node without draining it, and then the node will come back. But because if the workload is the engine, we're going to detect this replica has been disconnected for the short period of time, and the engine we are going to start rebuilding the replica and on another node. So in the next release, we're going to improve this. If we see that if there's a node with extreme big amount of data with replica on, we're going to reduce that data without like creating a new replicas and take some more spaces.
Okay, cool. I've got 2 questions here from Vipin. Oh, there's a couple more coming in now. So I'll ask them at the same time. What is the percentage of reserved disk space? Question mark. And is there any way to exclude a single node in a cluster, both from Vipin KT?
Okay. Reserved percentage space, that is one mark we put on the, for example, if you see that by default installation, Longhorn is going to use the disk at the Wallet Longhorn, right? That is likely going to be the root disk. And in fact, you don't really want to have your volumes data like scratching the root disk. Like, what if you have other important components running and cannot create cannot have a proper space to work? So we set the default reserve the space to 25%. That means it's for our Longhorn scheduling part, we try our best to not cross a line. So if we are using more than that, or we think your disk is going to use more than that, we're going to disable scheduling for this disk. So that is what's the purpose for the reserve percentage. So, but that is best effort, not guaranteed, because the volume, when volume start use, they can grow, and it's not much way for Longhorn to control that, because user can use to whatever he allocated. So Longhorn is by design thin provisioned and over provisioned, and if you think that the behavior of scheduler is more aggressive, and you can tweak those parameters like over provisioned percentage and the minimal available percentage, and those to increase the resiliency for your disk. And another question, what's the other question?
Any way to exclude a single node in a cluster?
Yes. So a few things. So there's for Longhorn, there are two kinds of nodes. One is the one kind of node that provides storage for Longhorn. So you can very easily just, if you don't want this node to provide storage for Longhorn, you can delete the disk on that node, and Longhorn will not going to ever consider that node for storage again. But also, if you are thinking about the worker node, which is going to use the Longhorn volume, not provide storage to Longhorn, but use the Longhorn volume, and those worker node need to be, it's basically every part, as long as there's a part, can be scheduled on this worker node, a Longhorn, sorry. So sorry, Longhorn need to be scheduled on, installed on this node.
Okay, so yeah, you've been talking a lot now. I think I'm probably gonna you've got a dry throat, no doubt. I'm gonna let you go in a minute. So Courtney's asked a couple of questions beforehand, has written, I'm a little confused. Okay, is storage provided by every node in the cluster, or can it be set to specific nodes?
Yes, it can be set to a group of nodes, which is, you can define that node to see, you can see that in the volume nodes page, there's one node and each node has a disk. If you remove that disk from that node won't able to provide storage to the Longhorn.
Yeah, okay. This one from Gregoire. Hello, I've got a question about the deployment of Longhorn. Let's say I've got a Kubernetes cluster with two server pool, with two servers in each pool. Is it possible to deploy Longhorn only on one pool, so 2 nodes, and used by the 4 nodes? Does that make sense?
Yes, yes. So that's it's effectively similar to it's similar to what I described before. So basically, Longhorn has the 2 kinds of nodes, and each node still need to be installed Longhorn to be able to use the Longhorn volume. But for the nodes that provides Longhorn volume, and you can simply just remove the whatever, just don't assign disk to them or disable the scheduling to them, and then Longhorn will not going to use that disk to use that node to provide the storage. So in your case, that as long as you just make sure that only 2 nodes provide the storage to Longhorn, and that will be fine. But by the way, we suggest have at least 3 nodes to do that.
Right, okay, cool. Question from Thomas. Is it guaranteed that the primary copy and the replicas are never co-located on the same node?
We don't have a concept of the primary copy. So the replicas are all contains the same data, and they are synchronized. So they are replicated synchronously. So there's we are guaranteed that so as long as you have hard anti-affinity set, which is default in the 1.0 release, they are not going to have any replica correlated on the same node.
Okay, and I think this is the last one. Can a node be retired and commissioned on the fly? That's from Fortis.
Yes. So because Longhorn has multiple replicas, and if you delete one node, and the next is at most is going to destroy 1 replica if you have hard affinity set to true, and that's a default setting, and you can just remove that node and delete replicas on that node and remove that node from Longhorn.
Okay, cool. So Sheg, I think I'm going to save your voice because you've been rattling away there for quite some time. So just to sort of conclude and wrap up, usual sort of stuff. Gregoire says thank you. No problem, Gregoire. Just in terms of resources, of course, there's loads and loads of resources are on the doc site, both on the Rancher site as well as on longhorn.io. Lots of documentation there. We spend a lot of time doing videos at Rancher, and you know, most, if not all of it's on YouTube. I mean, we do our own, so you can go to the Rancher Labs YouTube channel, but also highly recommend that you go and check out the YouTube channel of our Director of Communities, a guy called Adrian Goins. He's honestly, he's fantastic. If you haven't seen them before, go over there and check out some of his videos, including some that touch on Longhorn. And a relatively new addition, actually something organized by Adrian himself, and with William, who also features in the academy. The Rancher Academy launched well, I think 2 or 3 weeks ago now. It's been hugely popular. We've had thousands of people enroll and hundreds of people who have successfully completed the CRO1 course. It's completely free, so you have to part with no money. It's self-paced. It's lots of fantastic use of video. It's actually really pretty amusing as well. I've done bits of it too, and William and Adrian really they work well together delivering it. We've had lots of great feedback, I would highly recommend that if you are a Rancher user, as I suspect most people on this webinar are, to head over to academy.rancher.com and check out the course. It will be well worth your time. And that brings us to the end of this meetup. Thank you so much for joining. It's always a real honor.
Yeah, sorry. One thing I want to mention that in fact we have for the users like interested more in Longhorn, we have a Slack channel on the CNCF called Longhorn, and you register at slack.cncf.com. .io, and also we have Longhorn storage channel on the Rancher user as well. And for every second Friday, which for this month of the month, which is for this month is going to be this Friday, we have a monthly Longhorn community meeting starting at 9 a.m. Pacific time, and welcome to join. And we're going to share like more progress than the 1.0 and what's in the roadmap and what we have done for the last month. So
And also too, just one other thing, I'd love, Sheng and I would both love to hear your feedback about Longhorn and how you're using it. And we like to give things away too. So what I'd like to offer is if you share your story of how you're using Longhorn, we'll get you a t-shirt in the mail. It's our way of saying thanks, and also especially for just attending this today. And we really appreciate your time. The community is everything to Rancher. That's really what makes our company. So we're, yeah, hopefully please share what you're doing. We want to hear. And frankly, I don't know if you guys know this, you guys actually build the products at Rancher. We just ostensibly, are part of it, but it's your ideas and innovation that actually come up with the features. So yeah, don't be shy.
Okay, and with that, I wish you the very best, and have a safe day. Be careful out there. Take care. Cheers. Thank you.
Thanks everyone.